Fire Protection, Chapter 26. Okay, so the ATR Fire Protection System provides detection, warning, and extinguishing of the engines and nacelles, as well as the cabin. What is a nacelle? So you have the engine, and then around the engine you have some covers. Okay, the covers of the engines, they're called the nacelles. So you can have an engine internally, a jet engine, a compressor, a jet engine, or could have a fire internally inside. It could have a fire externally and is contained by the nacelles. Okay, you could also have smoke or fire in the cabin as well. Each engine is equipped with a continuous loop system monitoring overheat or fire. Okay, the engine nacelles are protected with fire extinguishers activated by the controls from the cockpit. So these are the two fire extinguishers. Okay, and when the pilot gets an indication of a fire, everything will light up. You'll get these fire handles light up, and he's supposed to pull the fire handle when it's illuminated. This will shut down certain systems and also arm the squibs. So the squibs are electrical devices here that cause mini explosions that perforate a membrane and will release all the halon gas that's in here and be distributed inside the engine to put the fire out. Okay, that's how it usually works. These fire extinguisher containers are pressurized with nitrogen gas, which is, by the way, also an extinguishant. But because of the pressurization, when the thing is perforated, okay, it will be distributed under pressure into the engine. Other than the fire extinguishers for the engines, we also, as we saw in the LOPA, we have cabin and smoke fire protection. So we have in the cargo compartments, the lavatory and the electrical panels in the cockpit are protected by smoke detectors. They're not protected by smoke detectors. Fire and smoke is indicated by, this is French again, indicated by panels, by indications in the cockpit, okay, to give the pilot the necessary information in order to be able to react. Okay, other areas in the cabin, there's no indications. If you see the fire, then it's time to extinguish it. The pilots might be able to see a fire in the cargo compartment because it's come on indicated in their panel, which then they tell the crew there is a fire in the aft cargo compartment. Please go and extinguish it. Okay. Smoke detectors as well are installed around the cabin area or in the cargo compartments. These are of the photoelectric type. All right, so we have a light beam that's projected onto a mirror back and forth, a couple of light beams or a cylindrical shaped light beam, depending on the manufacturer of these smoke detectors, how they do it. And the light is of a defined value, okay, when it goes through a certain, let's call it a prism from A to B. And then when the smoke particles, which are molecules of a certain density, depending on how dense the smoke is, when the smoke enters this smoke detector, the molecules interrupt this light beam. Once they interrupt this light beam above a certain threshold, the smoke detector then gives a warning electrically to the cockpit that there is smoke in the area because the light beam inside it has been interrupted by too many molecules of smoke or contaminated air. So we have smoke and fire indications all over the place in the cockpit. These yellow circled or yellow highlighted areas are all the areas where you can get information, or the pilot can get information about smoke or fire. We're not expected to remember them. It's just we're just showing you on how much importance is put on fire and smoke in this respect, because practically every panel, other than the two primary flight displays, every other display unit, yeah, it's got information on fire or smoke. Okay, we usually use the three MFDs, number 2, 3, and 4, different information. Okay, and we can get displayed information on forward or aft compartment smoke, cargo compartment, in the electronics racks, which sit behind the cockpit bulkhead. Okay, you will have got today as a freebie a picture of the electronics racks, which from my little black book. So in there will be smoke detection facilities, so that we can pilots can be notified if there is smoke in there, because smoke means probably some avionics system is overheated. The pilot needs to know about it. There's also, other than fire, there's also nacelle overheat detection. The nacelle overheat detection is a system where the pilot is informed that we haven't reached a fire yet, but the engine between externally, the engine between the outside and the nacelles is getting hot. In other words, maybe the ventilation of it is not happening. Maybe there's a duct or a ventilation duct that's supposed to be letting out the hot air there is not allowing it. It's blocked or whatever. So it's something you've got to keep an eye on, Mr. Pilot. Nothing to do now. You don't have to do immediate fire extinguishing, but you need to keep your eye on that. So, typical design of a fire detection system. We said it works on 2 loops. Every engine, or every fire extinguishing system or detection system has 2 loops, loop A and loop B. And for the fire to be detected, both loops A and B have to agree. Okay? So if both loops agree and the fire warning comes on, don't worry, you will know about it. Everything goes red, all the red ones. We said in lesson 1, what is red? Master warning. It means it requires your immediate attention. You're not going to do it after landing. You're going to perform immediate action now, and that's why it's red, and you get visual indication and an audio indication in the form of a certain call out, fire bell, whatever, okay, to wake you up if you're sleeping or whatever, to perform the necessary action. Now, these loops, they're in parallel, okay, and we said both of them have to work, or both of them have to indicate an overheat or a fire before the warning comes on the multifunction display. Okay, there's a series, you can see here, a series of logic gates. Anybody who's done a type course or is in their basics, anybody who did their basics and did Boolean algebra, okay, these logic gates operate as yes-no switches to meet the logic provisos to put the red lights on, okay, if there is a fire or not. So both loops have to operate. Both loops have to say yes, there is a fire, or if one is non-operational on an MEL, then the other one, the one working one, as soon as it comes on, will indicate a fire regardless, okay, because the one of them is in op and is already showing a fault, faulty, okay. So these logic switchings are performed in a little bit of electronics called the fire detector control unit. Okay, this contains all the logics, all the switches that decide if the loops are both healthy, and if they're healthy, then I provide a red warning when there is a fire, or another warning here if there is an overheat. Okay, these fire detection units are in the electrics rack 90 VU. Okay, sorry, 93 VU for engine 1 and 94 VU for engine 2. All right, and you can see them in that little handout you got today with all the boxes. The fire extinguisher models, it is a law, guys. It is not just for convenience, but fire extinguishing bottles are not allowed to be. They have to be separated from the engines by a firewall, by a bulkhead. Okay, so if anybody knows the 737, they put them in the wheel well. In the Airbus family, they put them in the pylon, which is separated by a firewall. And in this aircraft here, they put them in the wing to body junction fillet, they call it, on either side of the fuselage, well away from the engines. Okay, they're of the quick discharge type and have a dual outlet steel sphere. They have a pressure gauge, they have a fill and safety fitting, they have 2 discharge heads installed on the neck, and 1 explosive cartridge per head. So as soon as you command it to go, it will the explosive discharge head will penetrate the membrane and send all the contents to the fire, to the engine that has the fire. All right, the fire detector control unit itself, okay, has the ability to do bite. Remember we talked about bite, built-in test equipment. So it has 3 positions. Okay, it can test loop A, loop B for engine. For engine 1, you can test loop A or loop B, and the mid position is the off position, so to speak. Okay, there's push to test lights for loop A and B, the 3 position switch 1, 2, and 3 with automatic return to neutral position 2 after the test. There is instructions on how to operate these switches here on the front of the box. Here is a bit of a schematic on how it all looks. There's a control and indicating fire panel corresponding to each engine. Okay, they're clearly marked engine 1 and engine 2 so that we don't extinguish the wrong or shoot the extinguishant into the wrong engine. Okay, each panel consists of 2 push button switches, agent 1 and 2. Okay, so what does that mean? I'm using agent 1 and 2. So if I have a fire in engine number 1, for example, and I use agent number 1, okay, and it didn't put the fire out, I can use agent number 2 to extinguish the fire in engine number 1. All right, all controlled by those FDCU boxes that we saw in the previous slide. Okay, we can also do a squib test up here. Okay, the squibs are the electrical percussion mechanisms enabling electrical continuity of the percussion resistances to be checked. There's 2 push button switches for loop A and loop B. Each push button switch has 2 legends, 1 squib and 1 discharge, are an amber legend. So the idea is you get a fire warning, you get a red light. the instruction is pull the fire handle. By pulling the fire handle, the certain systems disconnect. All right. Any systems that the engine is no longer going to be using immediately will be disconnected from use, and then the squib white legend will come on, telling the pilot your squib is now armed and ready to go. Okay, so by then discharging the contents, okay, by pressing that squib white light, when it's discharged successfully, you get an amber discharge, D-I-S-C-H light come on, telling you that the contents of that bottle have now discharged themselves into the engine, and you should eventually get the red light, yeah, or at least the oral warning subside, because the fire should have now extinguished. Okay. The pilots get an instruction as well to perform certain functions, put the power lever into idle of the respective engine, okay, close the fuel off. There's no point having fuel going at 200 liters an hour, whatever, into a burning fire. So cut the condition levers, cut the fuel levers, the fuel switches, in order to starve the fire of any fuel. Similarly, we have indications for smoke in the cargo compartments, in the forward and aft cargo compartment ceiling panels. There's also smoke detectors as well for use or indication in the cockpit, so that the pilots can either themselves take necessary action or inform the crew to take the necessary action. Okay, the air extraction through the smoke detectors in the aft cargo and the toilet is performed by means of 2 fans. All right. So there is inbuilt systems in order to ventilate the cabin and use extraction purposes to get the smoke vented overboard if necessary. In case of one of these, there's 2 fans and they work alternatively. So if one fan fails, this is for this one, for the previous one, sorry. This one, there's 2 fans, but they work alternatively. So one is in operation, one is in standby. So that if one fails, you can switch to the other one and always have smoke extraction. Okay. If one of them fails, you'd have an indication, you'd have an instruction on the engine warning display, a QRH to the pilot to perform certain functions. Okay, this is the one with the underfloor. So we have air that's extracted from the avionics, is sucked out of the avionics and vented overboard or vented underfloor. Okay, vented under the floor. So the hot air is removed and vented underfloor, and then suddenly, if we have a smoke in the car, in the forward cargo or the avionics section, then we can't supply the smoke. We can't vent it under the floor. So we have a valve which we close the valve, and it will vent it overboard. Okay, through a device that they call a avionics vent valve that goes into the partially open position that will allow the aircraft, is closed enough for the aircraft to pressurize, but it's got a hole to produce a venturi effect to suck all the smoke from the avionics area or the forward cargo area and vent it overboard.